All right, so just we have a lot of folks here, so I'm just going to give you a quick introduction into what you've signed up for. Today's webinar is going to kind of go over how we're going to parse PDFs, but at a very deep sense in terms of understanding what it means to parse a PDF. And we're also going to cover how the unstructured platform, you can use the unstructured platform to do the same thing. Okay, so yeah, I guess it's been about 4 minutes, and we have a good amount of participants. I'm gonna get started. Thank you so much for joining again. Anyways, I'm Tarun. I'm based out of Seattle, and I'm a DevRel engineer over here at Unstructured. I'm going to be presenting the whole thing today for you. On the back end, we have joining two folks, actually. One person offered to join us at the last minute. We have Maria, who's the head of DevRel, who's going to be helping us answer questions that you might have. Um, you can feel free to drop those in the chat. And we also have Ajay, who's also a DevRel engineer on the team. Both of these folks are going to be really helpful with answering any questions you got. So yeah, so going into like a quick agenda of what we're going to be covering today. First, we're going to be looking at what unstructured is. For those of you who are not familiar and are coming to one of our webinars for the first time, we're going to give you a quick overview of what the product is and how we kind of help you unlock unstructured data. And then we're going to jump right into the problem, talking about what the problem is with parsing PDFs, all the challenges that are required, and how it kind of impacts your GenAI pipelines. Then we're going to go into how we use the unstructured pipeline to parse a PDF and what it looks like to parse a PDF using the unstructured platform. We're going to give you a whole double-click view into this, help you understand what the results are and how you're supposed to work through them so that you can now use them directly for your GenAI app. And finally, we're going to be going over some transformation strategies in terms of like what kind of for the kinds of documents that you currently have and for the problems that you're solving, what kinds of transformation strategies would help for you. So we're going to help you pick the right weapon for your use case. Just some quick housekeeping before we start. Like I said, first of all, if you have any questions, feel free to drop them in the chat. Maria and Ajay are with me to help you there at all times. They're going to be answering the questions as we go along. You can also drop your questions into that queue in the gray box, and we'll be able to answer those questions later in a follow-up email or something. Anyways, we're going to be also going to be sending you a recording of the webinar. So if you want to watch it later, recap some of the points that we cover, you'll be able to do so. And if you want to get a one-on-one chat to learn more about the about Unstructured or the product or anything of that sort, we can also schedule a guided POC and have a complete chat with you separately afterwards. So let us know. Anyway, let's start. For those of you who are unfamiliar over here, like, can some of y'all give me a quick drop in the chat for if there's anybody here who has no idea what unstructured is? Anyways, for those of you that awesome, we got a few folks coming in already. Anyways, Unstructured is basically a Series B startup, and the main goal of the entire company for us is to help organizations transform their complex unstructured data like PDFs, PowerPoints, emails, HTML files, and whatnot into RAG-ready structured data. Even like more broadly, we're just looking at GenAI-ready structured data because GenAI applications are extremely diverse now, and we want to bring all of this locked information into like unlocked content that you can directly use for all of these applications. We have a lot of customers. We've raised $65 million in founding since 2022. But yeah, we're a pretty big team now. So why did we get here? How did we get here? So, if you have built any type of GenAI application before, you probably started with something like a proof of concept with a simple subset of your documents that are neatly organized in like a storage location. You built your POC and then you wanted to maybe extend it into like an actual like production like pipeline, or an application. So then what? You start creating more pipelines to support that. And at the end of the day, you're gonna run into a quick rat's nest of pipelines, handling all of these different like features that you've built out. And what we call this is a pipeline jungle to prepare the data for actual production use cases. So this is, obviously because data doesn't come in neat, tiny, beautiful data sets like you just go ahead and download on Kaggle, right? Like in the real world, in a real organization, the data is spread across multiple different sources like buckets in AWS, or like Confluence or like Google Drive or whatnot. And this data itself also comes in like different kinds of formats. You might be working with like Markdown files and PDFs and like Microsoft Word documents. We had another customer come in the other day and say they were interested in parsing their Google Slides for some sort of use case. And each of these requires different kinds of like, strategies, different kinds of approaches to transform and then extract metadata out of them and whatnot. So then you're going to have to consider how you're going to be, like if you're say building RAG, right? Like you're going to have to worry about how you're going to chunk these documents, how you're going to store your secrets, how do you enrich the metadata over here, what kind of embedding models do you use, where are you going to be delivering the results? So many different questions that you're going to have to answer, that when you start with the POC and then you're trying to like add each of these one by one, you quickly have a very difficult to maintain pipeline jungle, which can easily be avoided. So Unstructured solves this precise problem by connecting to sources, getting your data from where it needs to come, and then you can build out your entire workflow internally to pre-process the data, extract metadata, do all of that, store it in a particular destination that you need to. And like regardless of what kind of source, what kind of file type, different kinds of partitioning strategies, enrichments, chunking, embedding, it's all part of the product. You don't need to bring in any of your API keys. You just need to come, use the platform for your documents, and you're now able to do everything end to end, set up your entire ETL pipelines, set up workflows, and schedule them to run and forget about them. So all of this is provided under one roof, and you don't have to do any of the work of like maintaining these pipelines. So for customers specifically who come to us, they've seen immense value out of this, because in the build versus buy conversation, they realize after trying to build it internally that buying something like this is usually the better option because of how easy to maintain and easy to use a product like this is. Anyways, let's kind of jump into the problem that we're talking about today, right? Like we're talking about the PDF paradox essentially, where parsing PDFs with like intelligent document processing that can parse PDFs is like a $1 trillion market right now. So many people are solving it. It's such a hard problem to solve. Why is it such a hard problem to solve? So PDFs itself, they're great to look at. You can easily, they maintain the structure that you create them with. When you send it to someone, you don't have to worry about their versioning of like, the structure changing or the formatting changing or anything of that sort. They're great to kind of preserve that visual fidelity, but they're not great to be machine readable formats of data, right? Like it's literally designed for human readers, but in a machine first world that we're living in right now, it's a nightmare for machines trying to understand this content, which is why any sort of like text extraction or like parsing or any of these very naive strategies instantly fail, because the biggest challenge, the first challenge that comes with reading any PDF is to understand the structure. So just like kind of looking deeper into like, why are these PDFs so damn hard to pass? So if you've ever like worked with PDFs before, trying to pull like text, trying to pull like tables and everything, the struggle that I'm talking about. You have to deal with like chaotic layouts, like missing structure, inconsistent formatting. So if you look at this example that we have on the right, you can see the whole chaotic layouts, right? It's an image, it's a bunch of tables, and then suddenly there's text in multiple columns. And sometimes when you're working with documents, they don't come as digital documents. They're like someone taking a picture, scanning the document and sending it to you. And that gets so hard to now process because it's not embedded text. It's now you got to do OCR on top of it. And when you do OCR, it's not perfectly accurate because the image might have visual degradations. It might have like a whole shadow on top of it, things like that. And on top of that, when you're looking at like, this example over here, formatting contains meaning in PDFs. Like when you see discussion as a title over here, that means something to you and I, because we know that that's a title. But like when you just run this through OCR, it doesn't really make that distinction and differentiate between these different kinds of elements. And that's the problem, right? It kind of misses that semantic layer in the backend. Like if you've ever seen the HTML code or seen what HTML looks like, that completely preserves the kind of structure and context that PDFs aren't generally designed for. But it is also the most popular file format in the world. So what do we do? So Unstructured kind of helps you make sense of these messy PDFs like we'd seen before. A quick overview, you pass the PDF as input. We run some transformation algorithms to extract all these different kinds of elements out of it. We process it further to do chunking, extract any metadata. We use like multimodal LLMs to extract tables and whatnot. And then you have a final output that you can now directly use for your GenAI applications. So kind of jumping into what the product itself is, the platform is to instantly give you an idea of how to do this using the unstructured platform. We have multiple interfaces for you to do this, depending on your comfort, your skill level, your how whether you're technical or not and whatnot. So obviously we have the unstructured API, which is a code first way to access our entire product. We also have the UI, which is a completely no code interface. You come, click, configure your sources, and then you're done. And recently, we also built out a very powerful MCP server where you can just open up Cloud and say, hey, can you take my data from S3? I want it processed using a vision language model, and then I want it pushed to this particular vector database. It's going to do that for you using the MCP server. It's a really, really powerful tool that we have been able to build very recently. So quickly jumping in, if you want to use the API, let's look at what it looks like to use the API to parse a PDF, right? We have two endpoints that we offer as part of our product. So like we had mentioned before, Unstructured primarily is a workflow orchestrator in the sense that you can come build your document processing workflow. You can schedule them and forget about it. So you can also use code to orchestrate these workflows. You can create workflows, you can run them, list them, create different connectors, create different nodes, do all of that, and essentially do all of this programmatically from your application. We also have a partition endpoint, which is for more rapid prototyping kind of use cases, where if you just want to see how chunking works, if you just want to see how the transformation on your PDF works, a single local PDF works, we have something that's more synchronous in nature, like that. You don't have to configure the entire pipeline for you to just come in and test that one component. So if you look at the code example on the right, I'm just going to quickly go through how simple it is to do this. You come in, if for people who are familiar with writing Python code, you just instantiate a client using the API key. You have a local file that you give a path to, and then you call the partition request, which is essentially the partitioner. You pass the file that you just that you want to parse using the product. You set your strategy, like how do you want this to be parsed. This is something we'll be going on over later, so don't worry if you don't understand this. You can also set some parameters like language that you're looking at, what kind of VLM that you want to use, and then finally, just call the request, and now you have a list of elements, and that's the output that you're getting out of this. At the same time, like I said, the unstructured UI is also a no-code interface that you can use to do the same thing. Once again, similar to how we have the workflow endpoint and the partition endpoint, over here, the platform can be used to create your workflows completely end-to-end. You don't have to handle any of your API keys or whatever. You just have to come in and configure your source and destination and the workflow that you'd like. But at the same time, if you don't want to do all of that and you just want to see how's this particular PDF that I have in my hand working with this transformation strategy, we have a new feature called the Visual Workflow Builder, which is essentially you can come and drag and drop a file, and it'll instantly parse that particular PDF using the workflow that you just created, and you can immediately see the results of what it would look like to parse that PDF using that particular workflow that you've configured. So just kind of repeating the difference. The API is code interface. The UI is a no-code interface. The API has two endpoints, the workflow and the partition endpoint. The workflow endpoint is to orchestrate complete workflows. The partition endpoint is to do more rapid prototyping. In the UI, you can once again come in and build out your entire workflows, configure your connectors, do all of that. At the same time, if you just don't want to run the entire pipeline, you just want to test one PDF, we have the Visual Workflow Builder that helps you drag and drop your PDF or choose from a predefined list of PDFs that we have on the platform. And you can instantly see the results of your workflow on how things are being parsed, how things are being chunked for your own visual understanding. So so both of these kind of methods generate the same output at the end of the day. What any form of unstructured document processing yields something called a JSON list of document elements, right? Like you have a JSON as the output, and the JSON contains a list of document elements. Think of an element as the atomic unit of your document processing output. It's basically every single component in your entire document. It can represent something like a table, a title, a paragraph, anything of that sort. And this kind of structure really helps you feed it directly into GenAI tools, right? So some common element types that you'll encounter when you parse a PDF are a title, a narrative text, which is just standard flowing parts of text, A table, an image, a header, a footer, all of these are individually identified and categorized for to provide kind of the structure that you're looking at. So if you look at the example that we have on the right, we have this is an example of an element that you would see. So we have the type as narrative text because it's not a title or anything, it's just like continuous prose. We have an element ID, which is a unique identifier for this element. We have the text that was part of this element, which the transformer was proposed in the paper and whatnot. And then we have some metadata that comes with it. We captured the file type, the languages, which page it is, and the file name that it's coming from. This is all extremely important. Like, let's say you're building, you want to add citations for your RAG. You can just easily pull out this kind of metadata, right? We're looking at the file name and the page number, and you're saying, hey, this text appears in this file in this page number. So all of this is automatically taken care of for you. You don't have to come in and configure any of this. So why did we kind of go with this document elements approach in the first place? Because like we had understood before, the unstructured, it's very important to not just understand your document, it's to deconstruct it, which is exactly what unstructured is doing. So maintaining that structure and preserving like the exact fidelity that you're seeing things with is extremely important. Knowing that, hey, the title exists at the top and, this text exists at the bottom, this is the footer and this is the header. All of this is super valuable when you're kind of, processing your documents because it's so much context that comes with it. At the same time, you also get a lot of granular control. Like, let's say I just want to look at the tables in my document, or I just want to weave through all the images on page 2 or do something like that, right? You can do exactly that because you can now go through your elements and pick and choose what you need. And like we'd seen, you can offer very rich metadata for every element of text in your document. You can bring things like the content, the textual content, the page number, the language that it has. And in some transformation strategies, you can even localize where a particular element occurs, like have the coordinates, and you can draw a bounding box around it, do very interesting things like that. So how do you kind of work with these different elements, right? Like you have your textual elements, but I'm just going to give you a very quick example of what it means to work with like images and tables. So for images, for certain transformation strategies, you can actually convert the image in your document to a base64 encoded string. And what that means is, imagine, for those of you who don't know, a base64 string encoded string is a way to take an image. Like if you take an image of me, you can actually convert it into a series of alphanumeric characters, and you can decode it back into an actual image. So we do that to kind of preserve all of the content that is being parsed through your document. And at the same time, for tables, which is, in my opinion, probably one of the hardest challenges in document processing, we actually natively support parsing tables in its HTML format. Now, what this means is that traditionally, if you've ever used like any one of these open source packages for table processing, the output is generally given in Markdown. We never understood that because there's so much more context that you can provide by maintaining more structure. So we natively support the HTML format, which kind of gives you preserve the exact row and column structure compared to a general Markdown based approach. So like the code example that we have here on the right is pretty straightforward, right? Like same thing, we have the response from parsing your document from your PDF. You have a list of elements. We go through every one of those elements, and we're looking for elements that are tables. And once we see a table, you can now kind of wrap it around in a HTML string, and you can actually immediately save it and look at it on your browser and see how the table was parsed by Unstructured. So for those, if you still don't kind of, are not able to kind of make sense of what's going on, I'm going to give you a visual example of what actually goes on in the backend, right? Let's take this document on the left. It's just a page from this random document that I found. It's got some text at the top. It's got a chart in the middle and a table underneath. So when you pass this through Unstructured, this is kind of how it's separating in the different elements that it finally generates in the JSON. So you see that it identifies the first paragraph as narrative text, which is continuous prose. It's not like just because it's at the top, it doesn't make the assumption that it's kind of the title or whatever. It's able to do the same thing for the image over here, the large visual, and it encodes that and it stores that. It also does OCR on top of this for all of these elements to maintain the textual information within the table or the image or whatever. Similarly, if you look at the table over here, it's able to perfectly kind of segment the bounds of the table And then it kind of does the processing separately so that it's able to accurately only get the information of that table out for you as a HTML format. So this is kind of a visual look into how unstructured looks at each page that you give it. So we've kind of seen how unstructured demystifies complex PDFs by like transforming them into a structured list of document elements. You've learned about these different various elements types so far, what kind of metadata that you're getting, and how this element-based output kind of readies your PDF, right, for whatever AI application that you want to build. This is extremely foundational understanding to unlocking the value out of your documents, because you need to know like data quality is so paramount for document processing that you need to understand what's going on in the backend, and we give you that complete look into what's going on. So we'll now kind of shift from what these elements are and how to generate these elements for your use case. So we have a couple transformation strategies that we want to talk about. We want to examine what their technology is, their strengths, their trade-off, and you will quickly learn to pick the best strategy for your document type and for your technical trade-offs. So obviously, PDFs aren't one size fits all. We might have different folks right here in the webinar. One of them might be just bringing like standard textual digital documents that they want to process that can directly go just pull out the text from the embedded text from these file formats and you can process them. There might be someone else who's going to bring in like I said, scanned images that they want to like also take the data out of and bring it down to some form of structure. These are very different challenges, different kinds of modalities altogether. So you can't just slap like one particular strategy on everything and expect it to work. We understand this problem, so we have different kinds of transformation strategies based on the different kinds of problems that you're going to bring to us. So in choosing this is paramount, because there are so many other kind of trade-offs that you're making, right? Like if you want high accuracy, it's how much are you willing to pay, what your latency should be. There's no such thing as free lunch for you to just come in and have something that works for everything. So depending on the PDF complexity that you're bringing, what kind of document quality that you're bringing, what kind of project requirements that you might have, what are you prioritizing for? We have different transformation strategies that you can select. I'm going to give you a quick overview of what these strategies are. So mainly, we offer three powerful kind of transformation strategies. The first one is fast. As the name suggests, it's really fast. It's meant for speed, it's meant for simplicity. It's best for the kinds of documents, like I said, that are digitally bound. You have like a text file, you have a HTML file that just has embedded information underneath, and you just want to pull them out and kind of chunk them and take care of all of that. Fast is amazing for you. It's going to be cheap, it's going to be fast, it's going to get the job done for you. But let's say you have something a little more complex. Let's say you're bringing in like research papers, or like something a little more complex with like multiple column layouts, or like images and tables and whatnot. You might want to try out a high-res transformation strategy, because it's literally meant to handle cases with like embedded images, tables, like different kinds of layouts and all of that. And under the hood, for those of you who are very technical over here in the webinar, and if you have some background in computer vision, you must have heard of object detection algorithms. So we have a custom YOLO-X object detection model that we trained on a large corpus of documents. And we also have some other very cool custom models, like we have our own model for OCR, for like table transformers and whatnot, that we have tuned to work perfectly for the document use case. So once we kind of, in high res, what happens is, you saw those bounding boxes in the visual example earlier. Once it identifies those elements, it's able to do OCR on these elements, get the text out, understand what kind of element it is. If it's a table, it sends it to our table transformer, and the table transformer separately processes those for you. And it's able to do all of these things without you having to worry about like what kind of models to use or anything of that sort. And the best part about high-res is it actually offers very rich element metadata. Now, let's say you're working on some kind of use case like, I don't know, multimodal drag, and you have to like also like pull the images and you have to like kind of generate images as your output, right? High-res allows you to store the images that are parsed as base64 encoded images like I covered earlier, and also store their bounding box coordinates for all sorts of elements. So you are able to localize this information within high-res very easily. So this works best for complex PDFs, but let's say you have something even more challenging than that. Like I said, you have scanned documents. You have like, handwritten documents that, don't work necessarily well with traditional OCR, highly complex layouts, that don't really even that are like posters or whatever, and like, or people don't really take good images, like I said, visually degraded images of the pages in your document. You might want to opt for something that's a little more complex, our BLM model. BLM stands for Visual Language Models. Imagine if any of you used ChatGPT recently, GPT-4o has the ability to take images as input. We are employing that to do to work for document processing here, and it's extremely powerful. It's so good at working and tackling all of these hard challenges that we have, and we also support all of the latest state of the art visual language models like GPT 4o and like Claude 3 Sonnet 3.7 and things like that, and you're able to uh, way more accurately do OCR and understand the layouts and extract information out of this in the same elements list format that we have, maintaining the rich ontology that Unstructured supports using the strategy. But at the same time, as we grow in complexity, your cost is going to increase, and it's also going to get slower to run. If let's say you kind of understand these different trade-offs, but you also have you're still not sure which one applies to you, or let's say your document corpus has a mix of all of this, we have something called the order strategy that is often like we recommend this as your best starting point. Imagine there's actually someone in the back end sitting looking at every single one of your pages and deciding what transformation strategy that it has to go through. That's what the order strategy does for you. Let's say you have a PDF. Starting off, you have a couple very simple pages with just embedded text in them, and then in the final few pages, you have scanned, documents. Order strategy automatically picks fast to run through the first few pages and BLM for the last few pages. So you're completely balancing performance, and in the long run, you're actually picking the most optimal strategy for each page while maintaining accuracy. So it actually gives you massive cost savings in the longer run. You don't have to use VLM on the entire document anymore. So just a kind of a deep dive into what table processing looks like, what the difference in these different processing transformation strategies looks like. Take the table that we just saw in the previous example with the bounding boxes, right? I actually just took the table from there and I processed it through high-res and VLM, which are two different strategies that we just saw. You're able to see that high-res is able to provide the table pretty accurately and quite gets it, but also not quite. Like the layout is something that it's not able to accurately capture, because this, in my opinion, is a slightly complex, table because you have multi-index columns. You don't really have like, proper like, separations, things like that. So being able to understand this layout is very easy for us as humans because we've seen so many of these and we designed it to kind of represent different things. But for a computer, like I said, you have these complex tables can be really confusing sometimes. So, but like, and high-res kind of struggles a little bit in terms of getting the layout just right, but it gets pretty much everything else right, the content inside and whatnot. Now look at the VLM example, right? It gets it perfectly right. It's able to understand that projection here does not have anything under that. It leaves that gap out for it over here and maintains the space and the layout exactly as it is in the original document. And fun fact, the kind of visual that you're seeing here, it's actually a HTML table that I used the exact code that I showed you earlier to parse and view on my browser. I just took a screenshot of that and posted it over here for you to see what it looks like to maintain your tables as HTMLs. So kind of summarizing what we have seen so far in terms of the transformation strategies. When you're building a generative AI application, I understand engineering teams, they'll come to you and ask you to evaluate the key technical trade-offs for your application, mainly speed, cost, and accuracy. And I'm going to give you a quick summary of the strategies that we looked at and compare it to these particular trade-offs. So for the fast strategy, you're getting the fastest transformation strategy that you have for the cheapest cost. But in terms of accuracy, it depends on your particular use case, right? Because if you don't have digitally born, just text documents, fast is going to struggle. It's not going to be able to pull out images for you and whatnot. Very simple documents, fast is your way to go. If you have something a little more complex, go with high-res. Evaluate it for yourself. Use it's medium in speed, medium in cost, because we've really optimized on our inference pipelines internally so that these models don't take up too much time to run. It handles way more complexity in terms of handling images, handling tables, and whatnot. But like I said, we just saw an example of how it's good at handling complex tables, but also not quite. So it's something that you're going to have to decide in terms of the complexity of your use case, which is why the VLM exists. It's the slowest, it is the most expensive one, but believe me, it's magical in terms of its its quality. It's so goddamn good. So that's depending on what your use case is. Let's say you're bringing in challenging documents, damaged documents, or with like occlusions, visual degradations, scanned documents, handwritten text. VLM is going to get the job done for you. And finally, if you don't know how to make this decision, go with Auto for starters. See how it works out for you. See how your document quality is. It's going to intelligently route all of the pages to the right transformation strategy and have it kind of collated in one single destination at the end of the day. So now that you've done, you have a PDF, you've parsed through it. I have my list of elements. I know which transformation strategy to pick. I'm a genius now, but I still need to build on my Gen AI application, right? Like, what do I do for that? Like, how do I kind of go about that? And what kind of features does unstructured support for that? You got to chunk your text at the end of the day, right? If you're building, let's say you're building RAG, you got to chunk your documents because LLMs have a context limit. You can't just pass all of your documents to the LLM. And we offer very different kinds of chunking strategies. We even have a contextual, excuse me, we even have a contextual chunking feature that automatically decides how to chunk your documents based on the semantic structure of your document. So all of this is something that's automatically taken care of for you and brings it out into optimally sized coherent chunks. Second thing, embeddings, right? Like you got to generate embeddings if you're doing RAG or any form of semantic search application. We support all leading embedding providers like Together, OpenAI, all of that. Generate embeddings on your chunks and index it directly into your vector database. Third thing is, you got to build metadata that we'd seen. We actually, as part of the workflow builder, we have some very interesting ways to enrich your content with metadata. Some examples are, first thing, you can do entity extraction, which is NER, like named entity recognition, on practically any task that you want that you define. You can come and write your own prompt and say, so I brought in some French text. I want to extract all the names or addresses from it. You can just prompt this, add it as a node in your workflow, and it's going to take care of bringing that metadata out to you in your destination. You don't have to worry about anything else. You can also generate textual descriptions for your image elements and your tables. And this helps boost retrieval quality because let's say someone comes in and asks, you're indexing a textbook, a science textbook, and someone comes in and asks, I want to learn about gravity, right? And there are visuals in your documents about gravity, but you also now have like these textual descriptions of those images. You're able to pull those as well as part of your RAG, and that helps boost your retrieval quality and provide way more context in terms of what needs to be returned to the user. Basically you're adding a lot more quality context to your LLM to synthesize better responses. Fourth thing, you can load into any preferred vector database that you want, like we have seen before. Let's say you come in with AstraDB, VV8, Pinecone, Milvus, name it. Even Amazon S3, you can. We have a whole list of connectors that you can see in our documentation that you can come configure as your destination, and Unstructured takes care of everything in terms of indexing, bringing it to the right format, how it kind of kind of upserts it into your document index, takes care of all of that. You don't have to worry about any of it. Like I said, you configure your workflow and you hit run and you just go to sleep. It's going to take care of everything for you. So and a side note, specifically for FSpec connectors, we also have the ability to reprocess only the newer documents. So like I said, when you schedule your workflows to automatically keep processing new documents that come in, we can do that. You're not going to have to pay for reprocessing your entire data set every single time. You can only kind of process the delta that's occurred every single time you run the workflow. And finally, like I said, you can schedule your workflows, set it for daily, weekly, monthly, however you like it, and it's going to keep running reliably for you and processing and storing all of your data in your vector database. So that's the end of the webinar. Thank you so much for joining. I hope I was able to kind of give you a guided understanding, starting from the very basic roots of what a PDF is, what the challenges are. We went over what it means to parse just a single PDF through the Unstructured platform, understanding and interpreting the results that come out of it. understanding the different transformation strategies that you can use to parse different kinds of PDFs, and finally, some insights like we just saw on how to build better RAG applications and the features that we have to support that for you without having to worry about any of the complexities of building it yourself. So thank you so much for joining. Please reach out to us if you're interested in a no-cost guided proof of concept. We're happy to set that up for you. But yeah, we can kind of move on to the question and answering section now. So if you guys have any questions, like we've gone over, feel free to drop them, and our team is ready to answer those for you. We have some questions as a part of our webinar that we were able to collect earlier, and maybe we can start off by addressing those. So, okay, hold on. Yeah, so one of the questions that we got, okay, so when parsing a complex PDF, such as compliance document, how can we ensure that the hierarchical context is preserved, including section, page, and optionally table and table column? Now, if Jay, if you happen to join our webinar, we went through exactly that, right? The whole point of using a product like Unstructured is intelligently preserving the structure and context of your document. So that's automatically taken care of for you when you process your document through this platform. Second question from Chris. Conceptually, I understand how you can embed an image, either a text description or an image itself, but I'm unclear how the search and retrieval works. That is, how do you compute a similarity score between a user query and an image embedding? It's an excellent question. So there are multiple ways to think about this. I'm just going to lay out all the different approaches you can take to solve this problem and let you choose what the best way is for you based on your use case, because I don't have too much context on it. Like we said, images are automatically parsed through the unstructured platform. You get it gets parsed in your vector database. The text inside it is embedded and it's stored in your vector database, and you're able to access these image elements separately. But if you're very specifically looking to get like the bounding box coordinates or kind of retrieve the image itself back into your RAG application, that is also something that we support, right? When you use high-res transformation, you have the base64 encoded string, and you can directly pull the image, decode it, and use it for any downstream application that you have. The third thing that's very interesting to me is the enrichment that we talked about. Generating text strategies, textual description from the images itself, and this is added as part of the vector database. So retrieval is automatically boosted because it knows that this image is related to this particular query that you're asking. So we do a text-to-text match to retrieve that respective image for you at the stage of retrieval. I hope that answers your question. So the next question is from Elliot. Where is your data stored? So we don't store any of your information personally. That's something we keep extremely private. We are something that I forgot to mention. We're enterprise compliant. We have all of the HIPAA compliant, SOC 2, all of that. We don't really retain any of the documents or train on the documents that you're parsing through our platform. And you actually take care of the entire start and the finish components of your document processing pipeline. You are configuring what your source is, if it's an S3 bucket, and you're configuring what your internal database is that you want us to push it into. So we don't really store the data anywhere in the middle. We just kind of push it directly to your destination. Next question from Darlene. Can you parse a PDF that is created from a scanned document? Yes, absolutely. That's why the VLM partitioner exists. It's great at taking care of images and scanned documents, and automatically parses it down to the same document or elements format that we saw earlier. Next question is from Conrad. Is there a good way to detect the mixed content in PDF, text plus table or image, or is it better to convert all to images and then OCR? We've gone through this over the webinar. That's a great question once again. You don't have to do that. We identify each of these elements for what they are, and we handle them individually in that sense. So you're able to kind of see a text as text, and an image as an image, and a table as a table. Okay. 1 second. Let me see if we have any more questions. Let me pull up the Q&A. 1 second, I'm just. Okay, so we have a question from Claire that says, how does it choose from the 3 strategies when using auto mode? Which that's something that we've built. So obviously we can maybe um, consider ourselves a little bit of experts in document processing at this point, but we understand the different kinds of strategies and what exactly each of them are best at doing. So that is our we have baked that knowledge into sort of a classifier that looks at every single page and applies that information to deciding which transformation strategy it should go through. Okay. I'm going to answer this question next. Can the system recognize hierarchy of titles in PDFs and add them into one and the same partition? Like one section is joined with the content of subsection into one. Can it work when the main header is number and subheaders are letters? Yes. That kind of contextual understanding is something that is something that automatically happens. So I can answer your question on 2 stages because I'm not quite sure which phase of the pipeline you're talking about. But when you're talking about chunking, you can choose how to chunk your information based on the title, based on subheadings, however you like it, or if you just want to do like a standard length as your chunk size, you can define all of these things there. So when you do things like chunk by title or contextual chunking, that takes care of your maintaining the different kinds of subheadings and subsections and all of that kind of information. I'm going to answer this next question. If I want to test the best possible approach for quality, including tables, fancy graphs, should I use the VLM and Sonnet 3.7? Yeah, that's going to definitely work for you. You might also want to try out the high-res, depending on what your technical trade-offs are. Pick the one that you're able to afford the most. Do you have a usage-based tier where we can just sign up and start using this entire platform seems to be, sorry, yeah, let me mark this. This entire sales and enterprise contract driven at first sight. That's a great question. And apologies if that's the kind of image that came after you during this webinar. No, this is actually something that anybody can use even for your personal projects. You can just go to the platform and use it for your own personal projects. At this moment, we would like to reach out to us if you're interested in using the platform, and we'll help you get onboarded and use it for your particular use case. But no, this is not a product that is purely for enterprise contract driven or sales kind of way. This is designed to be extremely user friendly in mind, and so that anybody can use it regardless of what scale they're coming in at. What's the difference between using VLM versus high-res plus enricher's table image? Okay, so VLM and it's just the ability to handle more complex images. VLMs are trained on a much larger corpus of data, so they're able to handle much more challenging documents and kind of implicitly do OCR internally. Whereas for high res, we use like traditional computer vision standards like an object detection model to look at the layout, OCR to extract text, table transformers to kind of extract the table information out separately. So we kind of break it down into more smaller components. VLM is like it's kind of talking about like how ChatGPT can do everything today, right? Like GPT models, in the textual modality are far more powerful, and these models are also way more powerful in that sense. Okay, when handling sensitive or critical documents, external API calls to state-of-the-art language models are often not feasible. What strategies do you recommend in such scenarios? Additionally, how close are we to having open source or locally deployable vision language models capable of accurately processing complex PDF layouts? 2 questions. Okay, the first one, If you're worried about security and obviously you can't make third-party calls if you have certain compliance requirements, Unstructured does in VPC deployments. It can completely run within your own ecosystem. The document never has to leave your ecosystem. We have that completely. We have a complete solutions team that takes care of that and kind of handholds you through that entire process. So if you're interested in something like that, please reach out to us and we can set that up for you. How close are we to having open source or locally deployable vision language models capable of accurately processing complex PDF layouts? Now, that's a hard question to answer because VLMs do exist today, and they can obviously, like open source VLMs do exist today, and they can process documents if that's your question, right? But okay, you need to kind of marry the complexity of your PDFs with the ability, with understanding the abilities of the VLM to process them. And that's where the challenge lies. Can your VLM reliably process your documents the same way over and over again? That's the challenge that we faced when we integrated VLM, and we were able to solve that internally. But yes, if you're able to kind of constrain the scope down to, hey, this is the exact types of documents that I'm working with. Can I use the local open source VLM to use it to do the same thing? Yes, you probably can. You're going to have to just figure out how to connect and get a VLM to do the same thing over and over again. How does Unstructured compare to something like AWS TextRact? They're both great transformation strategies. It's a very use case driven question at the end of the day. So for your particular use case, evaluate how each of these tools work. TextRact is purely a transformation product where you parse a PDF and you get a transform product out. Unstructured is kind of built to be way more than that. It's to handle the entire ETL pipeline, starting from your source connector, doing all sorts of chunking and anything that's required for your to make your data GenAI ready. Whereas for TextRact, it would fall under the realm of the first issue that we saw, right? It would be one component in your entire ETL pipeline, and you're going to have to build out all the other components to ensure that you get the same kind of output quality that Unstructured can offer. Okay. So I'm going to answer the next question. We are a contract furniture marketplace, and we work on aggregating furniture products data from our own suppliers. Usually, the catalog PDFs are very unstructured with images, blueprints, tables, descriptions all in one page. But also, the format can change from page to page on the same PDF. Does your model automatically understand what information needs to be extracted and how to transform them? Also, each supplier has their own formats. Yeah, at the end, you want the same result, from these catalogs. Yeah, so I think at this point, it's important for me to make a distinction to understand what unstructured can and cannot do. Unstructured is not going to look at your document um, and filter out any information out of it. It's not going to select what needs to be processed and what it doesn't. It's going to look at your document and going to process everything that it can that it sees within the document. It's up to you as the user to take and this is kind of the hardest part of document processing, right? We're solving that step for you so that you only have to focus on building any of these custom logic on top of that, like extracting the schema that you have, the kind of information that you need and whatnot. Uh, okay, so next question. I'm looking through these. We have some questions that talk about how does unstructured compare to like Azure or TextRact and whatnot. It's already been answered. It's different kinds of products overall. Hi, I'm Abu. I have some questions regarding partitioning strategies. Are there any comparative public evaluation benchmark performance between high-res and VLM mode for partitioning tabular documents? That is something that we are currently working on. Like we want to have public evals and that will be out soon, but we are able to kind of take in your documents and process them and show you performance evaluations that you might have. as part of like the onboarding process. Is it possible to combine multiple modes by using one API call to unstructured, like OCR, high-res, VLM? If yes, is there any specific order that tends to work well? No, because it's like doing the same thing. All of these strategies are kind of doing the same thing, and we don't exactly aggregate the information from them. But I mean, obviously, feel free to run your document through all of the different transformation strategies and write your own, like, based on whatever use case that you might have. You might want to like aggregate them a certain way or whatnot. But yes, you can do that, but not through a single API call. Those would be separate API calls. That's the difference. We're essentially trying to provide something that's flexible enough in a way that you can kind of twist it to fit into any kind of working use case that you have currently. Okay, I think I'm going to pick the last question and cover it. Okay. We have a question from Amitav. How can we handle some of the challenges with reading PDFs containing engineering drawings and drawing symbols, varied tables, etc.? That's something that, so the unstructured element ontology, like we saw, like tables, images, and whatnot, that covers a whole list of document element types that will go over all of this. So your engineering drawings are going to be looked at as images, and it'll also extract text from them and whatnot, and like, symbols and everything. But yeah, that is something that we automatically support as part of the platform, because we understand people comes with different kinds of complexities, and that's something that we cover over. All right, that's it. We're kind of short on time, so I'm going to stop with the questions here. Once again, I hope that was helpful. Thank you so much for joining us. I had a lot of fun kind of taking you through this journey, explaining how this works, and see you guys on the next one. Thank you.